Hey there. So you've seen rhombuses, rectangles, and squares a million times, right? But what if I told you they're all related? Like they're part of the same family. Today, we're going to dive into their family story and uncover the surprising connections between these shapes you thought you knew. I mean, let's be honest, it can get a little fuzzy. What really separates a rhombus from a square or a square from a rectangle? It seems kind of confusing, but stick with me, and I promise by the end of this, you're going to see the whole family tree crystal clear. And here it is. This Venn diagram is basically the official family portrait. It's the key to everything. It shows us these shapes aren't just a random collection of figures, you know? They're all connected. And understanding this family tree is the secret to figuring out how they all fit together. So, here's our game plan. First, we'll learn the family name that ties them all together. Then we'll meet each of the special family members one by one. After that, we'll see how the star child, the square, gets the best of both worlds. And finally, we'll put all these family traits to the test. Let's do it. Okay, first things first. Every single shape we're talking about today, the rhombus, the rectangle, and the square, they all share the same last name. They are all part of the parallelogram family. And that just means they all share one core feature. They're all four-sided shapes with two pairs of parallel opposite sides. That's the baseline. All right, let's meet our first specialist in the family, the rhombus. You can think of the rhombus as that family member who is just obsessed with everything being equal, specifically its sides. And that's its whole deal, right there. A rhombus isn't just any parallelogram. Oh no, it's a special one where all four sides are the exact same length. They're congruent. That is the one and only rule to get into the rhombus club. Okay, but this is where it gets really cool. Each of these special shapes has a kind of secret power, and it's all about their diagonals. For the rhombus, that secret power is that its diagonals are always perpendicular. They cross at a perfect 90-degree angle. You're going to want to remember that one. It's the biggest clue for spotting a rhombus. Now let's move on to another branch of the family tree, the rectangle. So if the rhombus is all about having equal sides, the rectangle is the specialist that's obsessed with perfect corners. I mean, the clue is right in the name, isn't it? A rectangle is a parallelogram where every single inside angle is a perfect 90-degree right angle. The sides can be different lengths, that's fine, but those corners, they have to be absolutely square. So what's the rectangle's secret power? Well, its own special rule says that the two diagonals of any rectangle are always congruent. That means they are the exact same length. If you take a ruler and measure from corner to corner both ways, those lines will be perfectly equal. So we've met the side specialist and the angle specialist. What do you think happens when those two sides of the family come together? Well, you get the star child, the square. It literally gets the best traits from both parents. Yeah, think of it just like that. To even be a square, a shape has to have four equal sides, just like a rhombus, and it has to have four right angles, just like a rectangle. It's not an either-or situation. It has to be both. It's the total package. And here it is, written down in the family rule book. The official rule says, a shape is a square if and only if it's a rhombus, so four congruent sides, and it's a rectangle, meaning four right angles. It has to check both boxes, no exceptions. And if we go back to our family portrait, you can see exactly where the square fits. It lives right there in the middle, in that sweet spot where the two circles overlap. It gets all the properties of rhombuses and all the properties of rectangles, which honestly makes it the most special and exclusive member of the whole family. Okay, so we get the family rules now. But so what? How does this actually help us? Well, let's see how these properties aren't just boring definitions, but are actually super powerful tools for solving geometry puzzles. Right, check out this rhombus. We need to find all the missing angles. We can solve this whole thing just by using its secret powers. First, we know the diagonals of a rhombus are perpendicular, right? So angle 1 has to be 90 degrees. Done. Next, another rhombus rule is that a diagonal cuts the corner angles in half. So if one part is 61 degrees, angle 3 has to be 61 too. And since opposite angles are equal, angle 2 is also 61. Easy. Finally, just look at that little triangle at the top. We've got a 90 and a 61-degree angle, so angle 4 has to be 29 degrees. See? No crazy math, just using the family rules. And here's a great real-world example. Imagine you're building a window frame. You measure it, and the opposite sides are the same length. So it's a parallelogram, for sure. But is it a true rectangle?
The only way to know for certain is to measure the diagonals. One is 54.8 inches and the other is 55.3. Since they are not the same length, that special rectangle property tells you, without a doubt, this is not a rectangle. Those corners aren't perfectly square.
We can even use these properties to solve algebra problems. So we're told this shape is a rectangle. We know its secret power is that its diagonals are equal. That lets us build an equation. We can just set them equal to each other. 5x minus 31 must equal 2x plus 11. And now it's just a simple algebra problem. We solve for x and we get x equals 14. If we plug that back in, we can confirm both diagonals are 39 units long. The family rule gave us the key to solve for x. So if you remember anything from all this, let it be these key diagonal properties. For a rhombus, the diagonals are perpendicular. They make a perfect cross. For a rectangle, they are congruent. They are equal in length. And for a square, our star child, it gets both. Its diagonals are perpendicular and congruent. It's the best of both worlds. And that leaves us with one last thought. Whether you're hanging a picture frame, laying down tile, or building a deck, you are working with these shapes all the time. So, the next time you need something to be perfectly square, how could you use what you just learned about its diagonals to prove with 100% certainty that it is? Something to think about.